Foosball, or table football, one of the oldest, most well-known games of kids growing up for generations. So I know what you're probably thinking. How do you improve a game that has been around since 1921? Do you invent some new rules or a new way to play? Well, not exactly. It's a lot more complicated than that. So we have a problem. How are we going to make the table smaller? And how in the world is this thing going to learn as it plays? Let me take you on our journey in creating the best foosball table of all time. This is all made possible by the newer and smaller actuator design of the AI Foosbot system, which allows for easy transportation and cut down on the size of the original foosball table by 90%. The new actuator design was a challenge as it had to take up minimal horizontal space, so we said bye to the second table and added an actuator shelf underneath the field of play. Took away the computer rods, added our revolutionary sleeve and cable system for our motion. The sleeve moves linearly on the square rod while the rod rotates, causing the players to rotate. Now, the fun part is that the table learns as it plays, and that wouldn't be possible without some crazy technology behind it all. The process starts with a 260 frames per second camera that sits snugly over the foosball table, capturing the ball position and velocity. The motor encoders return the position of each rod, both translational and rotational position. These inputs are sent to the system and fed into the deep reinforcement trained neural network. We crafted the training environment using a meticulous virtual copy of the physical table and programmed custom physics to accurately train and reward the AI before moving it to the physical table. Finally, how do we make this thing portable? The major electronic components and actuator assemblies are housed in our actuator shelf below our table. Caster wheels have been added that can hold 880 pounds, so we can easily lower and raise our table at will. This allows for easy transportation to any distance, even outside our building, like you see here, which never would have been possible before. And the acrylic covers are just there to make sure you don't hurt yourself. To test the table, we first tackled giving the neural network the inputs it needed and converting the outputs to a useful form. Through trial and error, we compared the forces and torques generated by the neural network and their effect on the simulation to what was happening on the table. Every new aspect of the physical table needed to be applied to the simulation. This meant retraining the model with every update, which is a process that takes several hours, even for the most powerful computers. This resulted in a very long time to get the two in sync. So everything we're doing is going to improve your gameplay experience. Well, thank you for watching. This video is made possible by CEAT and all of the great faculty and staff which supported our team. Have a great day, and don't forget, go Foosbots.